So we're going to toss Sphinx a problem where it's going to analyze some retail sales data and see if a product's average review that's been left by its customers is correlated to the actual product description itself that's written up front. And the product description is a string. We're going to use LLM-based methods to capture features from the string and see if they're predictive of the product's performance as measured by its ratings. This kind of could encapsulate a variety of phenomena. Maybe certain types of products just do better, but these products are all broadly in the same type of category. Or maybe product quality is indeed captured in the description, and we can use that up front to determine if customers are going to like it. So we'll toss this problem to Sphinx and see how it tackles it. So we'll say, can you load reviews CSV and product CSV, both of these local files, but obviously we could do this off of a database as well, and tell me if the embedding of the product description is a good predictor, if it's predictive of the average numerical rating. Giving it this problem, it starts to do some EDA right off the bat, starts to build a model. Before it can build a model, of course, it needs to join these two data sets together. You can see here that even right up front, we have like a product ASIN column in one table, we have an ASIN column in the other. Obviously not a very complicated thing for a human data scientist, but the kind of thing where Sphinx does need to build some intuition on what the data is, what the columns mean before it can actually even do the basic join. With that join in place, it should be able to now start leveraging our internal AI tooling. So again, I'll pause here to show it. That's using the Sphinx AI batch embedding functionality. This is using one of our LLMs that we host or that we're hosting on our server behind under the hood. But you can, of course, bring your own model. You can bring an OpenAI model, an Anthropic model, whatever you want. And Sphinx will help you orchestrate. It'll deal with all the nuance of the model code, whether you should use the responses API, the completions API, the prompt engineering, actually writing a prompt that makes sense if that's necessary to proceed. But we'll call this in batch mode. It'll run batch inference in parallel, speed it up a little bit here, but it can actually quickly get that done in a couple, like under a minute. And now with all those features that it's extracted, it can train a model. It's picked a ridge regression here, which I think is pretty reasonable given a lot of features. Seems okay. Hopefully it can improve that. So it seems to be now training a random forest instead, fixing a couple of errors with how it's invoking sklearn, and now it has a decent model. So I'll ask it, can you zoom in on that cluster? It seems like most of these products are quite good, high review products, and let's look at that manually and see what Sphinx has come up with. And we can reach a conclusion that this actually seems to have worked okay. Obviously not a perfect model, but there is some slight correlation between the actual rating and the predicted rating. The predicted rating here purely based on the product description, which is written up front. And this may be indicative of further phenomena that we can investigate, but really we've been able to get from a raw idea and some data to joining the data, cleaning out the null values, and of course using an LLM to build an embedding that we can use as a feature, and then actually validating the model with a couple of different model choices. In a total time, obviously having sped up some of the embedding and computation itself, total time around 5 minutes, definitely unlocking the ability to very quickly do deep dives into this type of retail data at a reasonably large scale.